Welcome back. In this video, we're going to practice using divisibility rules. For each number, we will determine if they are divisible by 2, 3, 4, 5, 6, and 9. As we work, remember, the goal is not just the answer, the goal is the reasoning. Let's start with the number 4,290. Divisible by 2? Yes, because it ends in a 0. Divisible by 3. We'll add our digits. 4 plus 2 plus 9 plus 0. That gives me 15. So, yes, it is divisible by 3, since 15 is divisible by 3. Divisible by 4. Let's look at the last two digits, 90. So no, because 90 is not divisible by 4. What about 5? Yes, because it ends in a 0. Divisible by 6? Well, yes, since it is divisible by both 2 and 3. And finally, what about 9? The digits add to 15, which is not divisible by 9. So 4,290 is divisible by 2, 3, 5, and 6, but not by 4 or 9. So now, let's look at another one. Let's look at 3,424. Divisible by 2? Yes, it ends in a 4. What about 3? 3 plus 4 plus 2 plus 4 is 13. 13 is not divisible by 3, so it's not divisible by 3 at all. What about 4? The last two digits are 24, and 24 is divisible by 4. What about 5? No, since this number does not end in a 0 or a 5. 6? No. Although it is divisible by 2, it's not divisible by 3, and we need both of those. And finally, 9. The digit sum is 13, and 13 is not divisible by 9, so no. So 3,424 is divisible by 2 and 4, but not by 3, 5, 6, or 9. So for our next number, we have 2,608. Is this divisible by 2? Yes, since it ends in an 8. What about 3? 2 plus 6 plus 0 plus 8 is 16, and 16 is not divisible by 3, so no. What about 4? The last two digits are 08, or 8. Yes, 8 is divisible by 4. 8 divided by 4 is 2. So yes. Divisible by 5? No, since it doesn't end in a 0 or a 5. What about 6? Well, no, since it's not divisible by 3. And 9? The digit sum is 16, which is not divisible by 9, so no. 2,608 is divisible by 2 and 4, but it is not divisible by 3, 5, 6, or 9. Next, let's check 1,999. Divisible by 2? No, since it ends in a 9. What about 3? 1 plus 9 plus 9 plus 9 is 28. And 28 is not divisible by 3, so no. Divisible by 4? Well, the last two digits are 99, and 99 is not divisible by 4. What about 5? No, since it doesn't end in a 0 or a 5. Is it divisible by 6? No, since it's not divisible by 2 or 3. And finally, 9. The digit sum is 28, which is not divisible by 9, so no. 1,999 is not divisible by 2, 3, 4, 5, 6, or 9. Finally, let's look at 2,791. It ends in a 1, which means it's not divisible by 2. Next up, 3, we need to add our digits. 2 plus 7 plus 9 plus 1 is 19. And 19 is not divisible by 3, so no. For 4, we look at the last 2 digits. 91 is not divisible by 4. Divisible by 5? No, it does not end in a 0 or a 5. Divisible by 6? No, because it's not divisible by 2 or 3. What about divisible by 9? No, because the digit sum is 19, which is not divisible by 9. So 2,791 is not divisible by 2, 3, 4, 5, 6, or 9. This kind of practice is valuable because it helps students compare rules and make decisions efficiently. As future teachers, it is also useful to notice where students struggle, like forgetting which digit rule goes with which number, mixing up the divisibility rules by 3 and 9, thinking divisibility by 6 only means an even number, checking too much of the number for divisibility by 4 or 8 instead of just the last digits. These are all normal mistakes, and they give us information about student thinking. You have now built both procedural fluency and conceptual understanding around divisibility. That is excellent work. The more you understand why these rules work, the more confidently and flexibly you will be able to teach them.